right, while we're waiting for the panel members, what I'd like to do is just go over a couple of how I'd like this panel to proceed, because what I'd like it to make this, I'd like to provide an opportunity, one for the students and then also for others in industry, to be able to talk with the different experts in different elements in different areas in robotics. What you have here, what we've assembled, are not only roboticists in the automotive industry, self-driving cars, but also in the medical industry with Dr. Felton in the factory floor, across many elements of robotics in the industry. So what I'll do is first give a short introduction of each one of our panelists. They'll then come up and give a little introduction about their company, as well as where they think the state of technology is today and where it's going in the future. And then I'd like to spur some discussion. So I'd really like all of you, young students, be thinking in the back of your mind as they do present a little discussion about technology to generate some discussions or some questions for them. Same with industry. Generate some questions so that we can have some discussion with the various panel members. So let me start with introducing each of the panel members. I'll do it in alphabetical order. We have Sarah Blackmer. Sarah is the Director for Government Markets at Pratt & Miller. She currently also serves in another role with the Robotic Technology Consortium, which is a national consortium of roboticists, both large and small, academia, etc. She's on the board of directors of the RTC as well as the acting treasurer of the RTC. Prior to her work at Pratt & Miller, Sarah worked with the Economic Development Corporation in Michigan, where she developed opportunities in defense and other federal programs for companies here in the state as well as academia. So she's got a very good expertise in federal programs as well as working with hands-on with actual industry here in the state. Her current work is in robotics and a little bit in the aerospace fields. Next is Dr. David Felton, right next to me here. This is a really interesting individual because I would say sometimes there's a few people that are just truly visionaries. And let me start with his education. So Dr. Felton received his BS, Bachelor of Science degree from MIT. So he was a technologist, a nerd, as the governor said. Then he went on and got his MD and PhD from University of Pennsylvania. So not only is an engineer, but then he decided to concentrate in neuroscience and those technologies for the medical profession. So he presents another view of robotics in a different domain. Okay, and what he currently, Dr. Felton is the Vice President of Research, Medical Director for the Research Institute at Beaumont Hospital. He also serves as the Associate Dean for Research at Oakland University, Oakland University's William Beaumont School of Medicine, and he's a clinical research professor of anatomy and cell biology, focusing in neuroscience at Oakland University. Then again, I'm going to keep going back and forth. We have Dr. Chuck Jacobus, and Dr. Jacobus is the president and CEO of Cybernet Technologies here in Ann Arbor, Michigan. He's had a long and illustrious career in R&D, focusing on many types of things, computer vision, artificial intelligence, you name it, many things. And a testament to that is he has currently 39 U.S. patents either awarded or pending at this moment. So his current interests are in robotic logistical specialty vehicles. Think forklifts, things like that. Marty Lin, next to Dr. Felton, is with General Motors. He spent 28 years with GM, and in 2000, Mr. Lin became the principal engineer of robotics for General Motors, and he managed a team that developed a programmable robot body shop. So now we're going into the factory floor, into manufacturing elements. On top of that, I do have to put this plug in, Marty, because this is really cool, being a cool nerd. He was the lead, he led the team, the GM team for Robonaut 2. All of us know Robonaut 2, right? And Robonaut 2 is currently a living member of the International Space Station.
Yeah, that's correct.
Yep. So here we have a nice cross-section. And then finally we have John Maddox. And John is he serves as the Director of Collaborative program strategies at both University of Michigan Transportation Research Institute and TTI. He develops new research strategies focusing on transportation safety, the environment, and mobility. He is very involved in the interconnected vehicle program here in Ann Arbor, where they are focusing on safety, mobility, and environmental impact of the transportation system. Prior to joining UMTRI, from 2008 to 2012, Mr. Maddox served as the Associate Administrator for Vehicle Safety Research at the National Highway Traffic Safety Administration. And before working there, he was also in the automotive industry for 19 years. So what we have, I think, is a really interesting panel of roboticists from many domains: medical, factory floor, logistical, high-performance vehicles for Sarah with Pratt & Miller, and interconnected vehicles. So please be thinking about these questions. I'm going to have each one get up and stand up and give a short presentation about their company, as well as where they feel the research is today and where it is going in the future. And you'll never have a better opportunity, students, to talk to real experts in the industry and visionaries in the industry to ask them maybe even career-changing questions. So be thinking about that. In industry, how do we connect if you're a small business looking to expand into robotics or expand outside your current niche into other domains? I think there's a lot of sage advice represented here on the panel that please feel free and be ready with questions. Okay, so let's start with Sarah. You're up.
Good morning. There's nothing like being the first person introduced on an esteemed panel just to hear the next guy introduced as very interesting. So sorry, but I'll do my best to not be super lame while I'm up here. I thank you very much, Andy, for inviting me, Rick and University of Michigan for having me. I got to tell you, I'm a Michigan alum, and there's nothing better than being in the big house, in my opinion, whether it's the first night game and we're taking it to Notre Dame in the last 70 seconds, or to be in this kind of a room to celebrate robotics. The big house is where it's at, so go blue. And thanks very much for having me. I'll also tell you that I'm really excited about this day particularly, and robotics and what the state of Michigan can do in robotics specifically. I was lucky to be a part of the planning group that put this event together 2 years ago. Rick mentioned that it was over in NCMS and much smaller, but still very large for this kind of an event. And the things that I think that are really important about this event is that it really showcases the capability set of Michigan as a whole. I mean, 2 years ago, 3 of the top 6 FIRST robotics teams were from the state of Michigan. And you just heard earlier from the governor that 10% of all FIRST robotics teams right now are from Michigan. So if you put those two pieces together, what you hear is there's a lot of teams from Michigan, but they're not just a lot of teams, they're really good teams. So congratulations to Michigan FIRST. That's pretty freaking impressive. The next thing I like to bring out is that we have a great density of technology capability in our universities. We put out in the top 5 of all states across the United States production and engineering degrees, and that's from all of our universities combined, and I think that speaks a lot to the capability set that our universities bring. And then finally, for industry, per capita, we hire and have in our industry base more engineers per capita than any other state in the nation, which I also think is hugely impressive. So there is a great density of capability, and putting them all together in the same room like we do for this event, to me, is super powerful. So that's all my spiel about this event. Thanks, Andy. So I will tell you, I am from Pratt & Miller Engineering and Fabrication, and we are a small engineering design firm, advanced engineering and design firm based in Michigan. We're just west of the city, Detroit, so we're east of here, this city. We are based in motorsports, but we take all of the wins from our auto racing technology and transfer those applications to defense, advanced automotive, power sports, and some pretty innovative type technologies. But rather than just hear me talk about our really cool technologies, I thought I would show you a video about what we do and what we can do. So if you guys can cue that up, please.
the success and the passion that we have for motorsports, it just permeates throughout the entire building. So when we have a project that is not motorsports, you really attack it like it is a motorsports program. It's got to be there to win and be successful.
We believe in our commitment to our customers. We have to win. We have the sense of urgency. We have the sense of excellence. And we expect to deliver on that every time.
You're either ready or you don't race. And I think that culture evokes a lot of really creative problem solving. Everyone really embraces that idea. If you don't, this isn't the place that you're attracted to.
One of the things that we consistently hear from our customers is how dedicated our employees are. Whether we send somebody to the racetrack to work on a race car, or whether we send somebody to a test for a military project, the customers are just so impressed with the dedication of our people and the skills that they have and the extra effort that they'll put in to make sure that their project goes off perfect.
It's that high standard of excellence, the pride and the passion that our people have, along with the technologies that we bring, with the processes that we use the technology. It's really that combination of the people, the process, the technologies that allow us to create just incredible customer satisfaction.
Essentially what we do for our customers is apply our advanced engineering tools and processes that are derived from our motorsports business, apply those to projects and problems.
We take projects from conceptual idea, and we'll bring manufacturing in, we'll bring fabricators in, we'll bring the customer in, and any other knowledge that we might have about the task they're trying to solve or the problem they're trying to solve.
Whether it's motorsports, automotive, defense, power sports, medical, it really doesn't matter what the industry is. We use these same tools and processes both on the computer-aided engineering side as well as the prototype manufacturing side, the test and development.
Our simulation tools and our analysis methods are integrated with our testing and development. Being able to layer on the advanced engineering methods and the analytical methods, put those two together, and that's really where it all comes together.
We offer soup to nuts capability. Anything that you're going to need to be able to design, develop, or build, you're going to find here.
We invest in the tools, the software, the hardware, whatever it takes to make sure that we're on the leading edge of whatever job we're trying to accomplish.
The fact that we have not just this very advanced engineering capability with our 100+ engineers in this building, but be able to walk 20 or 50 feet out the back door into the shop, meet with the fabricators, be able to take what's in somebody's head or on a CAD drawing and have that part or system fabricated is huge and very unique. We still operate as a small business. We've grown a lot, yet we still have this small business mentality. Motorsports is still very much at the forefront of our heritage.
We want to win, we want to be the best. That's why we all came to work here, and that's why we continue to work here, is to be the best.
We operate in what most people would think of as a constrained schedule environment, but for us, that's just normal operations.
Deadline's a deadline, and we will meet or exceed that deadline. So we bring that same approach, very competitive approach, high quality, only the best. And we don't do anything unless we do it right.
So as much as I embrace the governor and his platform of being a big nerd and loving that, at Pratt & Miller, we don't think advanced technology is nerdy in any way, shape, or form. We think it's super cool and pretty freaking sexy, and I think you can see that basically from what I just showed you there. So for all of you guys that are worried about, I don't know that I want to be a nerd forever, well, you're not, and don't worry about it. So we have a small division that I'll call product innovation in our company, which was briefly touched on there. That's outside of the lane of any of our big vehicle platform development, and that's where I think our robotics piece fits in. So we have some work that we've done for NASA. We do have some things that are in space right now on the space station, which we think is pretty cool. We have done some work with medical devices, and David, I'll be excited to talk to the very interesting person later about maybe what some of those things are. And then we've also done some really cool things with robotics. We see our robotics play as more of a platform development. So there are a lot of end applications where robotics can really help, whether that's in mining or agriculture or the oil and gas industry, we think is a big one for ground robotics that's emerging, whether it's for the Department of Defense. There are applications, and we think that we can help develop the platforms that enable those applications. We understand very well how to make high-performance advanced technology platforms, and so we see that mostly as our play. But within that, we definitely do a whole lot of mobility modeling. There's a whole lot of how much power do you need for, or how much torque do you need for which end application, depending on what you need, that we do a lot of analysis and modeling for that too, high end. There's a whole series of control systems, whether that's the algorithm and code writing development, or whether that's the hardware like the electronic wiring harnesses, and the combination of those control systems together, both the software and the hardware, that we also do very, very well for race, also for defense vehicles, but we see that as a nice application with autonomous platforms as well. Most notably right now, we are on Carnegie Mellon's team for the DARPA Robotics Challenge, which some of you may have heard about, which is their challenge to have a robot operate in a humanoid type environment, a human constrained environment, to be able to drive vehicles for disaster response. And so we are helping their team with, again, that torque modeling, how much power do you need, and what are some of these things going to do to your different systems from a modeling capability. So in a nutshell, that's what Pratt & Miller does, and I'm certainly happy to talk more about that later when you've got questions. But I do want to take just a couple of minutes to do a shameless plug for the Robotics Technology Consortium. Like Andy mentioned, I am on the executive board. I am the small business representative on that board. And the Robotics Technology Consortium is a consortium of industry and academic institutions that are in the ground robotics space. So we were formed in 2008, and this partnership was to provide innovative solutions in ground robotics, specifically for the Department of Defense, but we are looking to expand that customer base from Department of Defense to other government agencies, most notably, and we think most soon, would be NASA as a customer, and also the USDA, Department of Agriculture. Our membership right now is at 110 different organizations. Really, why is this a benefit for an organization to be a member? Well, I'll tell you there are a few. As a small business, what I think the biggest value is to being a member of the RTC is that they've executed $62 million in contracts over the last 4 years. So for me, in the ground robotics space, this is a great contracting mechanism. There's a lot of money that's flowing through there, and there's a lot of opportunities to partner because it is a consortium. So even as a small business, if there's only a piece of that I want to do, or that I'm really good at, or that I'm interested in, I can partner with multiple organizations to participate in some of those projects. The other thing is that it's really fast and effective contracting. So there's very quickly where a topic will be released, and then there'll be a response to the topic, and then it will go on contract. And sometimes with government contracting, speed is not necessarily what you find, but this tends to be very quick, so we like that as well. Just to give you a piece of what that looks like, there are two basic mechanisms. First is that the customer releases topics and ideas of projects that they're interested in, and the consortium can respond to those in an open, competitive manner, but down-selected as the consortium. If you're a member, you can respond. But then there's also an open selection process. So if you have an idea or a project or something that you think an end customer will be interested in, you can also put in a proposal for that, and it can be approved, and then you've already done the down-source selection competition. So if you find a customer later, they can put dollars on that contract, and now you have a contracting mechanism in place that you can use with any government contract customer. So it's a really nice thing. Also, as a small business, what I find very useful for this is that there's great networking opportunities, like I said, both to execute projects and then also to learn and understand different people who are in that space and what they can do. So as a small business, membership in the RTC has been a great thing for us. Obviously, I'm in the board, so it's been enough that we've invested that extra time and resource into participating in this. So there's a booth here. So if you are a business member, industry, please check us out, and we can certainly talk to you more about membership and opportunities involved with that. So Andy, thank you very much for your time. I appreciate it. And again, I'll take any questions you might have at the end when we open that up. So thank you.
Thank you, Sarah. So now we're going to go switch from high-performance race cars to medical. And Dr. Felton's going to give us some words.
Okay, thank you. I currently work in a very large industry, the healthcare industry. Beaumont Hospital is a 1,850-bed consortium or organization with 3 hospitals soon to undergo a merger with Henry Ford Healthcare. The combined system will have 37,000 employees, 7,000 physicians, a $7 million or close to a $7 million budget, operating budget, and we will be responsible for several million patients who come through our hospital system. In research, Beaumont itself has over 1,000 clinical trials currently going in hundreds of thousands of patients, and we're responsible for the well-being and safety, which is number one. Patient safety always comes first above everything else, including the happiness of anybody who may be there, the financial factors. If you don't have patient safety and quality of care, you have nothing in the healthcare industry. We're undergoing wrenching changes right now. We have to have an electronic medical record system. It has taken years to put in place. It's epic. We store hundreds of millions of data points in the system. We have to be able to access this. We need more than somebody swiping through papers, looking through paper charts, finding information. We need to be able to go and dig out records and make correlations and perhaps do data mining that is virtually impossible to do by hand. And we're in the midst of doing that. We use surgical robots routinely on a daily basis, the Da Vinci robot. It gives you better dexterity, it gives you better haptics, it gives you better capability of doing surgery with a finer hand and a finer scalpel cut than the human hand can do. But it does have a very steep learning curve. You have to practice, practice, practice. And you can't have somebody learning. You might ask, how does a student learn how to do a lumbar puncture? Practice, practice, practice. I'd just as soon not have them practice on me. So what we are doing is we set up a big simulation center where we have humanoid models. It's like having a robot right in your surgical center. And I just watched the other day, it's a competition. You have patient scenarios where you have your human laying on the table, or they bring in the patient and say, here's a teenage boy who just fell in ice cold water and has been in water for 10 minutes. Go. And the resident has to come in and look at him. What's his blood pressure? What's his heart rate? What are his vital signs? And if he's too slow getting something going, or if the physician, if she doesn't make a quick decision like that, boom, the blood pressure drops. So it's programmed so that the simulator can actually simulate an actual medical case. You talk about being under stress. And then there in the front row sit 3 evaluators, your residency program director, your preceptor, the chairman of the department, and they're sitting there watching you. And it's your responsibility to take care of that patient. So we need good simulations and robotics. Unfortunately, the Da Vinci robot is a big clunky device. We'd like to get them smaller, and we'd also like to get them so that they can learn and do surgery themselves. We've already accomplished having somebody perform surgery on a patient on another continent, where they can actually control the robot, the Da Vinci robot, from a great distance, from thousands of miles, and perform surgery. Absolutely stunning. And you can also integrate patient data, real-time imaging, and the ability to respond to unexpected challenges. But we still have steep learning curves with these larger robots. We've been doing some guided imagery which requires real-time manipulation of a system such as radiation therapy. As you may know, oftentimes radiation therapy sends a beam, a radiation beam, to kill off the tumor, and it does great damage to surrounding tissue. We have to be able to set up a system so we can evaluate where a tumor is in real time, bring the radiation beam in from multiple directions, that's called cone beam technology, And it was actually developed at Beaumont by our radiation oncology group. And then, as the patient is laying on the table, breathing up and down, the tumor is moving up and down. So we now have a system that evaluates the patient's breathing and moves the table up and down and sideways and backwards so that that tumor stays put where it's supposed to be, and you send the beam through it in multiple directions. You can hit the tumor with far more radiation. You can do it more safely. So it's a stunning new technology. We're now in the next generation tetrahedron beam, which is an even more astonishing technology, where instead of having a point source for the detector, you actually have an arc for the detector. So what do we need? We need physics, we need medicine, we need engineering, we need robotics with this. Now, we would like to be able to wire R2-D2 into our EPIC system and into our hospital system. Why? Because we have some situations where, for example, elderly patients fall out of bed, or on their way to the bathroom they fall, or their breathing pattern changes, and a nurse who's responsible for 27 patients or 6 patients or 3 patients, depending on how sick they are, isn't always in the room 100% of the time. We need to be able to remotely watch what's going on and then send the message very quickly to the people who need to know. That's actually quite exciting to be able to do that. Also, we need to do handoffs. Somebody coming from surgery into the recovery room, into an intensive care unit, into a ward, into an outpatient facility. Those handoffs are key places where mistakes are made and where things are overlooked. We need to be able to have a little R2-D2 hook into our system and say, oh, wait, you forgot the medicine, the pharmaceutical reconciliation. Do it. And they need to send up a red flag so that you can't proceed any further unless R2-D2 tells you to proceed further. And why is that important? Because with Obamacare, if you don't do it properly, you don't get paid. If you mess up and it's a never event that should never have occurred, you don't get paid. If a patient goes out of the hospital and comes back within 30 days, you don't get paid. So there are financial incentives. Those usually work pretty well at getting people's attention. They certainly are working well with the current hospital system. And if we put together this huge system with 10 hospitals, 200 outpatient clinics, it is essential that we be able to monitor this. No human being can do this alone. We need automated systems. One of the things I'm most excited about is the use of nanobots. And this may be something you read about in science fiction, but it's very real. Little nanobots that can go in and, for example, identify a tumor, and at the site of the tumor release a cytotoxic agent in such high doses that it will kill off the tumor cells, but if you ever injected that kind of concentration systemically, you'd kill the patient. So you have to be able to target the tumor, which means you have to identify a marker that little nanobot will recognize. And it recognizes it with antibody-antigen interactions as one form. We also would like to be able to go in and look at plaques in coronary arteries and identify, is this a stable plaque or is it a dangerous plaque? Is it an unstable plaque? If it's an unstable plaque, maybe we need to be able to digest some of the material or stabilize it by releasing a specific chemical. Or in the case of Alzheimer's disease, you've got aberrant beta amyloid protein there. We know that radiation will knock off that beta amyloid protein, but you can't just bombard in high doses a patient with radiation. So you'd like to be able to go in and hook onto the neuritic plaque and then release either intense radiation or release a chemical substance that will kill off that beta amyloid plaque and give the cell a chance to repair. And you might also release a growth factor at the same time to help repair the neurons. This is not science fiction, this is doable. But what do we need to be able to do this? We need to be able to identify specific biomarkers that can tell us exactly where that tumor is, where those neuritic plaques are located. We need to be able to identify unstable plaque versus stable plaque. And the only way we can do that is with excellent biomarker research, which is why I built a biobank and a core molecular lab at Beaumont that I think is second to none. It's an incredible array of technology all in one place under one leadership with all of the technicians so that we can put this all together and make it happen. And because of the coordination, because of the human factors of the management of how we run it, we're getting a tremendous amount of collaboration, I dare say even from some of our finest colleagues at the University of Michigan. Do they have the technology at the University of Michigan? Yes, they do. Can you get those 7 different instrumentations that you need from 6 different sites under 5 different principal investigators under 14 grants to collaborate? Maybe. Now, what do we need to be able to do? I think in order to be able to make this happen, we must have the partnerships, and it requires partnerships with the biotech companies, universities, hospitals, and government. There's no way we can do this without, because each person has a contribution. For example, we work with Lawrence Tech that sends us engineers, and in fact, we employ some of the engineers as well as have students there, and they are helping us identify which joint procedures that have been done surgically are progressing well towards healing or are not, and we need to be able to go in and, again, using some of these strategies, be able to release growth factors that will stimulate recovery better in the sites where they're not repairing as well. The disincentives that we see that we need to work on are straightening out the whole IP issue, the intellectual property issue. Somebody owns this, and if it turns out to be lucrative, and it's a combination of government, industry, universities, and hospitals, of course, they're all going to ask, so who gets it? Who gets the intellectual property, and who's going to make the money off of it? And if you work with government grants, there are all kinds of rules and regulations. I know you're shocked that government would have rules and regulations, but you have to develop it in certain ways. Also, the university tenure and promotion policy oftentimes encourages individuals to work independently, autonomously, and as silos. That is not conducive to good collaborative research unless you offer incentives to the person to work collaboratively as part of a team, and you indicate that a team effort is worth as much as an individual R01 grant from the NIH. That needs to be done. There's also the issue of capital. Somebody has to be able to fund this. And from the looks of how our federal government is going, we're going to have some challenges in the future with the current sequestration and the decrease in funding. So we do have some challenges ahead of us, but what an exciting era to be working on everything from the macro robots that can help us do our job better and keep patients safer to these stunning technologies that can get nanorobots or nanobots to go in and do things that we only dreamed we could do in the past. The technology is actually here. We just need to put it together. Thanks.
Thank you, Dr. Felton. Great discussion showing a large range of technology to employ in medical. The next person is Chuck Jacobus, and Chuck usually has an idea a minute. So I'm expecting some really interesting discussion points from Chuck here. Come on. Okay, Chuck.
All right. With that introduction, now I have to live up to it, I guess. My discussion points are really sort of more along the lines of what your career in robotics may look like. I was always interested in machines. I always programmed computers and built things. And somebody told me in graduate school, it was at Illinois, not Michigan, sorry, but somebody in grad school said they were making intelligent machines in that lab over there. And I didn't believe them, because I'd done enough programming. I didn't think you could make intelligent machines, really. But I figured it would be fun to go and see. And I'm still at it, and we're still not making intelligent machines. We're still just trying to. But what I did have learned over the years is that most of the interesting robotics gets carried on the back of things that people don't want to do or can't do very well. So in the beginning of my career, we built a lot of semiconductor manufacturing robot machines. And the reason your iPads are as cheap as they are is because that was done about 30 years ago. And it's gotten better, but it started then. Later on, I was working in a research lab here, actually, and I was always interested in computer vision because that seemed to be, to me, an area that had to be solved, but it required intelligence and lower level signal processing, and it seemed like an interesting mix. So I got involved in a bunch of programs. Originally, the original autonomous land vehicle program actually at DARPA was catalytic. It was actually done as a consequence of us being concerned the Japanese were going to take over robotics and computers. And so DARPA funded a bunch of programs. The most interesting one to me was the autonomous land vehicle. And it turns out it was a lab here that made the sensors for that made it work. A company called IRM that's no longer around. But a lot of our small robotic spin-off companies are derivative of that company. When we first started CyberNet, we got compelled to think about how to make a little money. That's sort of what you do. And so we were looking for, there's a phrase that one guy from the 50s, and I forget his name, he basically said, if you want to drink with the glasses, i.e. drink champagne, you got to sell things to the masses. Well, we got thinking about that, and we actually started. It turns out you probably all have robots in your house. You may not know it. You probably do though. If you have an Xbox controller, and or a cell phone, and it vibrates, turns out that's a robot. It was actually developed. We actually in our company developed those things in the early 1990s. In a very huge format for NASA, so it had nothing to do with games. But subsequently, through the 90s, it got cheaper and cheaper and cheaper to make that stuff. So by the middle 90s, it was in cell phones, and by the end of the 90s, it was in almost all kinds of little interface devices like Xbox controllers. What we're interested in right now is, we sponsored one of the DARPA Urban Challenge teams to put a little plug in. We were driving autonomous vehicles in Michigan before it was licensed back in 2007. Probably the first autonomous vehicles that were driven on Michigan roads. In the first series of this meeting, we actually had one of our cars out there in the parking lot giving rides until it broke. And it broke because it was raining that day, so water got in the works. What we've done since then is we've been thinking about where is this technology going to be adopted first for vehicle robotics. And because of our relationships with the Defense Department and other commercial companies, we've come to the conclusion that it's probably going to be in specialty vehicles, things like logistical vehicles that bring things from place to place. So with that, I think I'll show a video, which is something we're pretty close to finishing right now. And this is actually a forklift that drives at near human capability. So it can mix with human forklifts or human-driven forklifts. And it's actually originally, its first application will be in the area of ammunition loading and unloading, because that has a tendency to be dangerous, and so the Army's willing to not worry too much about what it costs. Turns out, though, the cost to automate this forklift is about half the price of paying a forklift driver per year. So the commercial company we're working with is actually getting ready to launch this kind of commercial forklift in the next year or so. Right now what you're seeing it do is you're seeing it actually drive by itself. There's nobody in there. And it turns out on the ammunition application, it has to do really tight maneuvering. So it's actually using computer vision to get itself through that little door, which has got a 3/4 of an inch on either side of the lift truck. Here's another video of the thing. Now there is a guy in this one. There's a safety. This was a demonstration, so people were around. So it has a safety driver in there. But if you watch his hands aren't touching anything. And what it's doing is it's acquiring pallets of about the size of an ammunition load, and it's putting them into a lot of ammunition in an organized way that's based on the way they like to do it. They like to basically put the pallets in from the back forward. So first it goes in and it says, well, I'm not close enough to where I need to be. So now it's backing up on its own. It's lining itself up with this row of pallets. it goes a little farther, because of the way the sensors work, it goes a little bit farther beyond where it needs to be. Then it backs up and looks, which is what it should do in a second. Maybe, yes, yes. It's always so slow when you're watching it on a video. But when you're giving the demonstration, it's always fast because you're worried it's going to fail. Okay, so now it's fine. Now it's lining it up. Now it's lining that pallet up with where it's decided it's supposed to go. Now it's going to do a really dramatic movement. Yep. It turns out it can see it can see out the back better than it can see out the front. So it's actually got the pallet inverted. Now, because it's got short forks, it has to actually see where the pallet's going down. If it's not far enough, it goes and gets it again. So now it's done. So this kind of forklift thing can pretty much replace all the drivers in a warehouse or in a place like a Home Depot when they want to restock at night. And we're doing the same thing with other specialty vehicles. So, this is what you do if you're in robotics. You invent stuff. It's pretty much all there is to it.
So if you didn't know, Chuck's also very bold. I don't know if I would have stood up here and said I drove an autonomous vehicle on the roads 10 years ago, but
Well, no.
there's Department of Transport. Okay. No, it's fascinating. The next person we have in line for you is Marty Lynn from General Motors, and he's going to, as I said before, talk manufacturing and some other ideas for robotics.
Thank you very much. I'm Marty Lynn from General Motors. I've been to many events like this where I sat in the back and kind of paid a little bit of attention, the person talk. I can tell you it's a lot easier sitting back there, over there somewhere, than standing up here and actually talking and making sense and entertaining you. So appreciate the opportunity, Andy, for coming up and talking to the U.S. First kids and the other people that are celebrating Robotics Day here at U of M. I am, full disclosure, I am an alumni of the university, so it's nice to come home and see the stadium. This is pretty awesome. This is the first time I've been back since they remodeled, so it's pretty cool. I always like the opportunity to talk to kids and people that are excited about robots because, honestly, I'm a robot guy. I like robots. I'm the principal engineer of robots for General Motors, which means I get to dabble in all kinds of things robotic, both from the production line to things in R&D and talking about the future. And I think in order to understand where companies are going, where the technology is going in the future, I think you have to also look at the history and pay a little bit of homage on this Robotics Day to the history of robots. So maybe the next slide, here's the clicker here, got it. So the next slide, the General Motors, of course, is auto manufacturer. We build vehicles, and I don't know if you guys knew that or not. We also use a lot of robots. In the company mission to design, build, and sell the world's best vehicles, we're all about vehicles, autonomous or in the future, and those that you drive right now. But in the course of actually designing, building, and selling those vehicles, we use robots. We use a lot of robots. I would venture to say that we're probably one of the world's largest users of industrial robots. We probably buy somewhere between 3,000 or 4,000 robots per year that we actually, these are industrial grade robots, we buy them, we design applications and processes with them, that we install them, we start them up, we program them, we debug them, we actually make products with them. And we have engineers all around the world that use those robots. And what's really important to us is dealing with the supply base, dealing with the robot manufacturers, and so having commercial agreements, having the ability to go and get robots that work first time out of the box, install those things into our plants, and then do what we call a flawless launch. That is, it's really important for us once we start we take the production system down and then we actually install new equipment, we want to be able to make production as soon as possible because we don't get paid unless we actually make those products. And then the other part to that is we are global. We are a global company, so we have manufacturing operations all around the world. One of the things that helps us be able to do those flawless launches is our robotics technology and how we actually execute and implement robots. Not just from the standards and the programming standards, but you really have the same robot, the same equipment, whether it's somewhere over in Asia or Europe or South America as you do here in North America. So if there's a problem, if somebody has a problem with the robot, and you can imagine as you're trying to keep your robot that you've built for US First up and operating, we have those same kinds of problems except multiplied by, say, 20,000. So again, it's really important for us to have a common approach to looking at how we do our robots. And then we also are looking at robotic technology developments. How do we enhance our product quality? How do we enhance our manufacturing operations? Safety is our overriding priority. We really want to make sure the operations are very safe for our operators and that they are the most efficient as we can possibly make them. This is an eye chart. It shows a little bit of the history of robotics within General Motors. We have a long, rich history, including the first implementation of an industrial robot in manufacturing. Way, way, way back at the Turnstead plant. It says 1961, is that right? Yeah. It's 1961, so I almost wasn't born then. In a long time, and there's all these different things that have happened in between up until the development of the Robonaut 2 device, which I'm hoping that some of you have seen that. There's a picture of it there on the International Space Station on that slide. It has been launched and is now a permanent resident up there. General Motors has been part of all of that. So robots are really important to General Motors. We really we use them pretty much everywhere. Here's some more pictures. Again, I think it's really important. You talk about going forward in the future and you talk about cell phones and laptops. We've been using robots for a long, long time, and I think it's really a testament to the importance of the robot in manufacturing, just the fact that it's still around and we're still here pushing, trying to make things better. Okay, so here's some pictures of robots in our current applications. We have tooling robots, we have standard industrial robots. We use robots really in every part of our manufacturing, from the stamping, from the foundries, to the body shop, paint shop, general assembly for glass install. We use them everywhere. Spot welding robots, just thousands and thousands of these things all across the globe in every one of our manufacturing plants. So if you're looking for a job in robotics, there's probably going to be one at least as long as we're doing manufacturing. Oops, I went the wrong way, sorry. Okay, so the problem that we have is as we look towards new applications of robots, and I think Andy or Rick, somebody had mentioned the coming onslaught of this new class of robots, of human-safe robots. We are conflicted as an end user, as a manufacturer of automobiles. We're a little conflicted because we really need to have the industrial reliability. We need to have the robustness of things that we're going to build, and it's going to work. It's going to work for millions and millions of cycles, and yet we also want to have the advanced capabilities. We want to have the ability to do all of these new things, have all the new technology, the latest and greatest, really to be able to be the lowest cost and most efficient manufacturer of automobiles. And so doing all of that while you still have safety and you still are cost effective is a very, very difficult task. But very clearly we see the future as going forward towards humans and robots working together. We see that as a key enabler for us to be flexible. It's a key enabler for us to be competitive. The automobile industry is very competitive, And we really think that that's a differentiator. How we use robots, how we apply those robots to our manufacturing process really is going to make a big difference in our long-term viability and long-term competitiveness. We do see robots as having a broad use and application in both products and the manufacturing in our processes. So thank you. Look forward to any questions.
That's fantastic. And the last speaker, John Maddox, is going to be talking about interconnected vehicles probably, and working maybe even at NHTSA that's been supporting that.
And that is right. Thank you, Andy. Good morning, everybody. I don't have any cool slides. Andy told me not to bring any. I think that's probably because he's seen my slides, and so I'm just going to talk here. I'm from University of Michigan Transportation Research Institute. I'm a U of M grad. That's University of Maryland, by the way, not Michigan, but happy to be here in Ann Arbor. It's a great town. We at UMTRI conduct research in transportation, primarily in safety of transportation. We've been around for about 40-some years. We work with a lot of folks that I see here in the room, vehicle OEMs, government agencies, states, the Michigan DOT, and of course heavily within the university with College of Engineering or our School of Medicine or School of Information. And I think your comment about collaboration being difficult within the university, you're absolutely right on. Collaboration's in my title. That's what I'm supposed to do, and it's a very difficult challenge, as a matter of fact. And historically, UMTRI has focused on, in fact, safety has been focused on the occupant protection in a crash. And if you think about, you've all seen crash test dummies. Those were the kind of the state of the art of development 30, 40 years ago. And a lot of that work was done actually at UMTRI. But now we're focusing primarily on crash avoidance, because if you can avoid the crash in the first place, you can really create a much safer road environment to begin with. As mentioned a couple times, well, before I get to connected, we've been doing a fair amount of work on sensors on vehicles. To sensors, algorithms, sensors like radar, camera, and ultrasonic devices to be able to detect other vehicles in the space. But right now we are conducting the safety pilot, which has been mentioned a couple times, and how great is it that that the governor of the state recognizes the need for connection. Safety pilot is all about the study of connected vehicles. Connected vehicles you could think about is like an internet for cars. It's cars talking to one another. It's cars talking to the infrastructure. And I think the analogy of our computing systems is a really good one here, because think about those of us who are old enough to remember having a PC on our desk. It did cool things. You could do some word processing, but really the value came when you connected these computers together in the internet. And then we had literally an explosion of ideas, of technologies, of developments. I think the same thing will happen in transportation when we connect cars together. The reason also that we're very focused on this connection aspect is because we think it can potentially address 80% of the crash scenarios that happen on our roads here in the United States. And if you think about the fact that we have about, I think it's around 6 million crashes in the U.S. every year, around 33 or so thousand fatalities. That is the equivalent of 6 Iraq-Afghanistan wars every year on our soil. That's just an unacceptable situation. And now we can really do something about it, because we can connect these vehicles together and we can automate them. Connection also brings great opportunity in information exchange, not just for safety, but also for mobility. It truly could ease congestion, especially if you can provide real-time lane level, let's say, traffic information to a driver while they're driving. It also can really incredibly change the efficiency of the way we operate our vehicles. Because you can reduce crashes, there'll be less congestion. Because you can reduce congestion directly, there'll be less fuel wasted in congestion. So there's a lot of potential benefit here. And we're running the world's largest test on connected vehicles right now here in Ann Arbor. We've got about 2,800, 2,900 vehicles equipped that are actually all talking to one another. We've got, we'll be running for about another 6 months, 9 months, and then the U.S. government will make a decision on how to proceed to require this technology on all vehicles in the future. This study is generating a lot of interest from companies and organizations that are not typically your transportation. So we're getting, we've had lots of discussions with Cisco, Intel, Siemens, Google, Navtech and Garmin, et cetera, AT&T, wireless providers. They all want to know how this can be applied to their world. So now we're seeing this connection between connected vehicles and automation, and it really is important. So now we're getting into the automated vehicle space, and primarily we're talking about road vehicles. We're not directly doing any work on off-road or specialty vehicles. So my comments will be primarily focused on the road, and we're interested in self-driving cars, and I'll get back to that in a second. Primarily because I mentioned there's those 6 million crashes. 93% of which are caused by human error. And we are all human. We all have errors. We all make errors, and that's never going to change. But robotics, particularly automation for vehicles, can reduce the effects of human error on driving. And theoretically, again, we're looking at maybe an order of magnitude reduction in those number of crashes, which would be a revolution for our society. We're working on, I think, a couple of key problems now. As I'm sure you're all aware, the basics of sensing and deciding what to do, those are difficult problems, especially when you're moving at 65, 75, 80 miles an hour. We're also working on reliability and cybersecurity, because any system we deploy has to be reliable, and it has to be secure. It can't be hacked from other folks from the outside. Interesting also, we're looking at driver acceptance and HMI issues, human-machine interface, and maybe that's kind of ironic that one of the hardest problems in automation is actually how that robot interacts with the human, because that is how things will start here on our public roads. There'll be a change. There'll be a sharing of responsibility. We're also looking at early applications like vehicle platooning. Platooning obviously is when you can get vehicles following at very close distances. A lot of value there. One, fuel economy. You can potentially increase fuel, save around 6 to 8% of fuel usage in heavy vehicles through platooning. But also maybe we can really increase the capacity of our infrastructure without having to build more roads. And that is a game changer, because we really, as a country, are not building many more roads now. We have to do better with what we have. So maybe I'll shift gears a little bit and talk a little bit about how automation has been proceeding. And Marty from GM, of course, GM's been, frankly, at I think one of the key leaders in automation for vehicles for quite some time. There's been a basic research going on for about the last 5 to 10 years, I would say, pretty heavy. But in the last year to 2 years, I think that is accelerating greatly and will continue to accelerate for the next 5 to 10 years. And GM and Google and other companies really are at the lead there. There's certainly been getting a lot of press, but what I think most of the time what's going on never gets press, because it's still being developed. So if you see this much, it's the tip of the iceberg. There's a lot more going on than what you see in the press. I think we need to be very careful about how we refer to these things. And I've heard the word autonomous a number of times today. And maybe for a forklift, that truly is autonomous, or for a medical device, that truly is autonomous. But I think, as I mentioned earlier, we need to be thinking that for public road usage, there will be a sharing of control between the robot and the human. And these vehicles really will not be autonomous. They will be subject to human control most of the time. And if they're not subject to human control, they're still connected to one another. They're not acting independently. So I think autonomous, for those reasons, is the wrong word. I think we ought to be talking about automated vehicles. And there, as I mentioned, I think as Governor Steiner or some other folks mentioned earlier, there are levels of automation. And we'll start off with on the lower level, where the driver can cede control under certain circumstances when he or she wants to. Not the other way around. The robot will not tell the human when it will take control, I don't think. And certainly they will use communication. I'll give you one example of where communication, connectedness, and automation work hand in hand. Is one of the key problems of any robot is to be able to to locate and identify an object, figure out where it is and what it is, and maybe a little bit about where it might be going in the near future. If you connect those vehicles, the other object can tell the robot exactly what it is, where it is, and frankly where it's been for for the last 500 milliseconds or even a couple seconds in some circumstances. So that connection can provide information that the robot cannot get necessarily by itself. And I think that will be critical. So I think in the next 2 years, we will see early deployments of low levels of automation. We're already seeing it now, frankly. Vehicles are coming with adaptive cruise control, but if you join adaptive cruise control and a lane centering system, you've got the makings of a pretty capable highway robot. And that will be the first implementation. And then we'll move on to other applications, as I mentioned earlier, platooning of vehicles, but also driver assist in stop-and-go traffic is a pretty simple problem. Low speeds, lots of time to make decisions, kind of staying in a lane most of the time, just have to follow the car in front of you. Then we'll move on to higher levels of automation, and I'm not going to put a time frame on that, but it's not 2 years. It's longer than that. And driverless, I know people use those words. That will be a long time away. And you can actually envision some very beneficial driverless applications. The one I like to talk about the most is kind of an automated valet. Imagine you pull up to your place of work or your home, and you don't want to park the car. You just want to go into the office. So car drops you off, and you go tell it to go park itself. That's a pretty compelling, I think, application, because parking is priced upon its location. So if you can park for half the price 3 blocks away, wouldn't you rather do that if you can? I think so. And maybe that might be one of the early driverless applications if we ever get there. But I think certainly there will be many, many new applications that we can't even envision today, just like the internet. I want to talk a little bit about Michigan, because I firmly believe, as the governor and others stated, that Michigan, I believe, is the place to be for vehicle automation, for the work that will go on in the next 2 to 10 years. I think Michigan will be a hub of connected and automated vehicle development, along with other countries. We shouldn't pretend that the U.S. is the only place working on this, because there's a lot of work done in Japan and Europe, and they will continue to lead in some areas. But Michigan, as it's been mentioned, is home to many vehicle OEMs, many manufacturers, including what I would consider the leaders in automation. Home to TARDEC, the military Center for Ground Vehicles, of course. We have a very forward-thinking political leadership here in the University of Michigan, here in Michigan. And let me say, after having spent 4+ years in Washington, having a politician or a bureaucrat that gets the technology, that's a very rare thing. It's an incredible thing, actually. So here we've got the makings. I think of course, we have top-tier universities. We've got state-of-the-art connected and automated test facilities and tests actually going on right now. I think we're going to see an increased initial deployment of connected vehicles here in Michigan. I think that this is the place it's going to happen first. So we are very well positioned. And I think it's going to be a very exciting time to be working in robotics in general and the automotive industry specifically. So look forward to the discussion.
Okay, thank you, John. I appreciate it. I want to open it up the floor to questions. As you, I'm sure, surmised, we've got some real experts here. We're blessed with the state having a great, robust robotics industry, but also with organizations and individuals that are really the leaders in this area. So let me open it up. Questions? Yes. Here we go.
I'd like to thank our sponsors. We're from Willow Run High School. We are Team 66, one of the first teams. And I'd like to thank our sponsors, Sortec and General Motors, and tell General Motors you guys could add one thing to your history slide. 2002, we partnered with you to win the World Championships. So you could add that to your DARPA. Okay. My question is, looking around, there's a lot of amazing nerds here. But it bodes the question, what is being done in the industry to reach out to the underrepresented populations?
So explain the underrepresented.
Minorities, women, Hispanics. I look around and see a lot of homogeneous population here, and we know that the population in this country is changing, and it's changing quickly. So how are we as an industry responding to the changes in population?
robotics.
Yes.
Let's, Dr. Felton would like to take one shot at that.
From, let's see, is this on? From our hospital, we actually have summer programs that we make available to underrepresented groups. And in fact, we go out and try to identify people in our laboratories who are interested in having summer students come in and work on a project. And we've been able to do this especially in some of our big programs like orthopedics, which has been just a pioneer in this kind of work. And now in our biobank, in our core lab, where we are identifying molecular markers, we've got stunning technology in that core lab and biobank, and we're having students, initially college students, and then it went down to high school students, and now we're having students in the 7th and 8th grade coming to us asking us, can we please come in and do a project? It becomes a challenge with the employer having students under 16 in an environment that may have some risks associated with chemicals or machinery or materials. But if anything, we have had outstanding success having underrepresented populations of students come in and work with us. Oakland University does the same thing with our Oakland University William Beaumont School of Medicine, and Lawrence Tech, who we associate with fairly heavily for our engineering program, does the same thing.
Anyone else? Okay. Hold on one second.
Actually, to amplify on this co-op idea, anybody who wants to be a co-op, anybody who wants to support in some of these teams like the first team, we unfortunately support a team downriver, but because we have employees that have kids in it, but that sort of thing is probably the best way.
Okay, any other questions? Yes.
Yes, I have a question for Marty Lynn. For GM on automatic guided vehicles, where's you going with that, and how far are you going to advance? Are you going to have automatic guided vehicles that don't follow a program path or a tape on the floor? They can move independent.
Okay, so again, the full disclosure here is my field is in manufacturing, but I can tell you absolutely, I mean, automated vehicles, as was described by the previous speaker, is clearly part of our future. I think there's a huge commitment of resources in terms of R&D and development just to be able to manufacture those types of products that, again, for all the reasons that were brought up, with the infrastructure aging, with the all the other elements that we have in terms of saving fuel, and yeah, we're going to have automated vehicles in the future, I believe. I don't know if did that answer your question?
Okay. Can I add a question to that?
Yeah.
Can these automated vehicles be made to access real-time information about where there may be auto accidents or where the road is in such atrocious shape that you'll tear the bottom of your car out if you drive over it? Or possibly situations where there are so many orange barrels. You know, if only I had been smart enough in the 60s to invest in those companies that make orange barrels that block off lanes during traffic, I'd be rich. But
So right now, there are things available on the OnStar, on your OnStar-enabled vehicle that will allow you to see traffic conditions, will allow you to see accidents. I don't know about the road conditions, but absolutely, that stuff is actually available right now.
And you can build that into your automated vehicle?
Absolutely, yes, correct.
Maybe add one thing to that. One thing to that is, what I didn't talk about was data. And if you think about using that internet analogy, the internet also revolutionized the way we get information and share information. The same thing will happen on vehicles. You actually can use them as individual probes or sensors. And as a matter of fact, theoretically, you can actually measure directly surface coefficient of friction, for example. And we are testing those kinds of applications right now.
the availability of data is so important because right now the NIH is demanding that all medical research be made accessible to the public. You're paying for it. You have a right to know what the money has been spent for. So getting data available so that people can peruse it and utilize it and understand it and perhaps extract information from it to go to the next step instead of hiding it is a very important step. That still is a challenge with small businesses that have trade secrets and tend to sequester their data and not make it available until after it comes out. But making data available has been a big push with some of the agencies and will continue to be.
Okay, we have one more question. Is that okay, Phil? Just, you can, okay, thank you.
What are the challenges in front of us that need to be solved to allow me to drive to Florida and overnight and while I'm sleeping?
Are you talking about tomorrow?
Hire a valet.
Yeah, there's I think a number of problems, and they will be solved. I honestly believe. And interestingly, as I said earlier, that the engagement with the driver is critical, especially because you have to often hand off between what the robot can control and what a human needs to control. Because, for example, if you've got if you've ever been to California and on their interstate system and seen one of their freeway merge areas, for example, or anywhere, you get almost chaotic movement of vehicles when they're merging and leaving the freeways. If the exits are spaced close together, you get this kind of mixing bowl effect. Robots have a difficult time handling that, frankly. Humans are quite good at it most of the time. That's one example. But definitely you hit on something I think that's really critical is if you think about the way our roads are used, we put trucks and cars and everybody's kind of driving in some peak hours, and most of the time the roads are relatively empty. Heavy vehicles don't often operate at night. They don't like to operate at night because drivers get tired. Well, maybe we can shift that model around when we can really, the robot can drive for a driver. Maybe the driver can go to sleep and be woken up at the right time when needed. So it might really revolutionize the way we use our current infrastructure. But there are challenges that still remain.
Yeah, the biggest problem, and he touched on it, the biggest problem is that the current state-of-the-art of automatic driven robot cars have problems understanding objects. They're pretty good at knowing where they are. They're pretty good at being controlled, but they're very good at knowing about potential collisions. But they're not very good at knowing objects. So, for instance, somebody decides to do road work along the way. It's loaded with objects that are odd, and they're not normal. Another example is just simple things like road signs and stoplights. We see them easily. Robots actually, I mean, I think the best state of the art right now is seeing those things with computer vision at about 97%. Well, 97% is running a red light about every 20 or 30 times. So it's not, that's sort of the challenge. And actually the connected highway approach to solving that problem is probably the nearest term approach.
Also, I would say from a non-technology perspective, I think two really big inhibitors right now are public perception of how safe robots are and just quite frankly the safety rules of putting things on the road. So there are a lot of OEMs, automotive companies that are reticent to put some of these things out for public consumption just yet because quite frankly they're not proven to the level that other systems are. And that requires a lot of data, like was mentioned before about the importance of data. From a public perception perspective, how do I trust that the robot's not going to kill me? And we've got 30 to 35,000 deaths right now in automobile accidents. So let's say automation of our vehicles decreases that to 20,000 a year. That's not what you're going to see. What you're going to see is Robo Terminator car killed, 10,000 people this year versus it saved 10,000 lives. That's just not what you won't see. So, two maybe non-technology things that are kind of holding us up maybe are those.
Okay, I have to call quits. I'm being lassoed off here. I want to thank the panelists. What a great set of experts. Thank you for your questions. By the way, they are captured here the rest of the day, so if you want to ask more questions, just find them. Okay, thank you.